Hi, everyone. We are going to talk about something today called the triangle inequality theorem. Sounds pretty fancy, but really it's just a way of proving that a triangle is truly a triangle. We can't really just pick any three numbers and say that it would be possible to create a triangle with those side lengths. There's actually a specific rule that tells us if that triangle can actually be made using the three numbers that you chose as side lengths. So something I usually do in class with this is I usually have some spaghetti pieces and I would have you guys create triangles and non-triangles, and we would talk about which side lengths were able to make a triangle and which ones weren't. Since we're not able to do that right now, we're just going to talk about what the theorem is and go about it that way. So basically, the theorem is when the smallest and the medium sides of a triangle are added together, their sum will always be larger than the largest side. Okay, so basically we are looking at the three side lengths that were given and we are adding the smallest one with the middle one. And if that sum is greater than the longest side, it can be a triangle. Okay, so let me show you some examples and that will probably help. So if you look at number one, I'm just going to label this as the largest side, this as the middle side, and this as the smallest side. So the theorem says that if I add the smallest one plus the middle one, if that sum is greater than the largest one, then this works. Well, 9 plus 12 is 21, and since 21 is greater than 15, I would be able to make a triangle with those three side lengths. Okay, we'll do the same thing for number two. So this is the largest, this is the middle, and this is the smallest. So if I add the smallest plus the medium, I need it to be greater than the largest. Well, since 23 is technically not greater than 23, it's equal, this would not form a triangle. Okay, so the sum cannot be equal to the largest. It has to be greater. Okay, so for this next one, I'm going to add the smallest plus the medium and see if it's greater than the large. 19 is not greater than 20, so this is a no. Number 4, the small plus the medium has to be greater than the largest. 6.5 plus 8.5 is 15, which is greater than 13.5, so that would create a triangle. Number 5, we have 28 plus 47. Those are the two smaller. And is that greater than 70? It sure is. 71 is greater than 70, so that would create a triangle. Number 6, if I add the two smaller, I need it to be greater than 41. And in this case, I get exactly 41, so that would not work. That is not greater. So can't make a triangle out of that. 5 plus 10, is that greater than 15? Nope, for the same reason. Can't be equal. And our last one, smallest added together gives me 15, which is not greater than 16. Okay, so that is the first of the triangle inequality theorems. The second one talks about how the sides and angles are related. Okay, so in any triangle, the longest side is always going to be opposite the largest angle. And the shortest side will always be opposite the smallest angle. Okay, so I'll show you what I mean by opposite. So it says to name the largest and the smallest angle. So in number 1, what I want you to do is first find the smallest side. Okay, so the smallest side would be AC. Remember, we name sides using two letters. Okay, so side AC. Now the angle that is across from that side is going to be my smallest angle. So when I say across from it, I mean right there. Okay, so angle B would be my smallest angle. Now we'll do the same thing, finding the largest angle. So we're going to find the largest side, which in this case, side AB is my longest side. So the angle across from it, angle C, would be my largest angle. Okay, looking at number 2. Let's do the same thing. So to get the smallest angle, first I look for the shortest side. So the shortest side would be FE, and the angle across from it is angle D. For the largest angle, I'm going to look for the largest side, which in this case is DF, and the angle across from that is angle E. Okay, turn the page. So now, instead of me giving you the side lengths, now I gave you the angles, and I'm asking you now to tell me the shortest side and the longest side. So in number 3, to find the shortest side, I first need to find the smallest angle. Okay, so the smallest angle is right here, 47 degrees. So the shortest side is the side that's across from that, which would be right here. And remember, when we name a side, we have to use 2 letters. So side AB would be the shortest. To find the longest side, we're going to find the largest angle. So the largest angle is right here, 70 degrees. The side across from it is the longest side. So that would be side AC. Okay, let's do the same for number 4. So the shortest side is across from the smallest angle. So 25 degrees is our smallest angle, which means the side across from it is ED. Now, if you said DE, that's okay too. The order doesn't matter here. For the longest side, this is going to seem obvious, but I'm going to prove to you why. So 125 degrees is our largest angle, and so the longest side is across from it, which would be EF. Okay, now in number 5, we are missing an angle. So it is very important that before you start classifying, naming your shortest and longest side, that you first find out what that missing angle is. Okay, so we did this in the last lesson. The 3 angles of a triangle add up to be 180 degrees. So to find that missing angle, the first thing I'm going to do is add the 2 that I know, and then I'm going to subtract that from 180, which tells me in this case that my missing angle is 75 degrees. Okay, so now that I know that, I can find the shortest side because now I know the smallest angle is 40 degrees. And so the side across from that would be side AB. And to get my longest side, I look for my largest angle, which thankfully I found the missing one because that happens to be my largest angle. And so my longest side is across from it, side AC. Okay, so those are the 2 triangle inequality theorems that we need to know. This last part is review from the lessons that we've done so far. So my advice to you would be pause the video, try these 5 questions, and then replay the video from here and see if you got them correct. Okay, I am going to work through them just as if I were explaining it, just in case you'd prefer to do it that way. Okay, so number 1 says, find the complement of an angle whose measure is 37 degrees. So remember, complement means that you have 2 or more angles whose sum is 90 degrees. So if I'm asking for the complement of an angle whose measure is 37 degrees, it means that some angle plus 37 is going to give me 90. So to find that missing angle, I'm subtracting from 90, and I'm getting that the complement would be 53 degrees. Number 2, find the supplement of an angle whose measure is 55 degrees. So supplement means 2 or more angles whose sum is 180 degrees. So if I know one angle is 55, my other one I can get by subtracting 55 from 180. And I'll get that the supplement is 125 degrees. Okay, number 3, angle B and angle C are vertical angles. If angle B's, what is this? If angle B's, let me get rid of that, measure is 65 degrees, find the measure of angle C. Okay, so if you remember back to our lesson about types of angles, vertical angles mean that they are across from each other and they are congruent. So if I had to draw a picture of this, it might look something like this. Angle B and angle C. They're across from each other and they're congruent. So if I know angle B is 65 degrees, that means that angle C is exactly the same. Okay, so that's the definition of a vertical angle. Okay, number 4. Angle A and angle D are complementary. The measure of angle A can be represented by the expression 4x plus 5, and the measure of angle D can be represented by the expression 2x minus 11. Find the value of x as well as the measure of each angle. Okay, so the important thing here is that we know that these two angles are complementary, which means when I add the two angles together, I will get 90 degrees. So in order to figure out what the value of x is and the measure of each angle, I need to write an equation. So I'm going to start by saying angle A, which is 4x plus 5, plus angle D, which is 2x minus 11, needs to equal 90 degrees. Okay, and so I can solve it from here. If I combine like terms, I get 6x minus 6 equals 90, which then I would add the 6, and then I would divide by 6, and I would get that x is equal to 16. Okay, so I'm almost there. Now that I know x is equal to 16, I can figure out the measures of each of those angles. So I'm just going to write up here, the measure of angle A was 4x plus 5, and the measure of angle B was 2x minus 11. So now that I know what x is, I'm just going to substitute 16 in for it, and that will tell me the measure of each of my angles. So 4 times 16 is 64. 64 plus 5 gives me 69 degrees. And for angle B, 2 times 16 minus 11. So 2 times 16 is 32, and 32 minus 11 is 21 degrees. And so there we have our two angle measures. Now what I would do just as a quick check is make sure you add those two together. 69 plus 21 gives me 90, which is exactly what I needed to happen. Okay, last one here, number 5. Is it possible for a triangle to have angle measures of 38 degrees, 110 degrees, and 33 degrees? So what they're getting at here is, do you know what the angles of a triangle need to add up to be? Okay, so no matter what, the angles of a triangle have to add up to be exactly 180 degrees. So if we add these angles together and we get 180, great, it's a triangle. If we don't, it's not. So let's go ahead and do that. 38 plus 110 is 148, and 148 plus 33 is 181 degrees. So we would say, no, this cannot be a triangle because the sum of the angles is more than 180 degrees. Even though it's only a degree off, it's just not possible. All right, great job, guys.